Hi and welcome to this video about NTFS streams. So what are NTFS streams? As it happens, NTFS is a rather unique file system. It has several unique features, one of which is alternate streams. The idea here is that every stream is its own data, its own piece of data. You can have multiple streams, in fact, technically any number of streams within the same file. What we typically think of as the file content is actually a default stream that has no particular name. In fact, every stream has a type, and there are a bunch of predefined types provided by NTFS, most of which are used internally, not really fully documented, not really for outside consumption, but there's the kind of a default type which is called a $data, which is the default kind of stream we can write. Let me show you what that means, what that looks like in terms of tools and in terms of code. So first, let's look at a bunch of files I have here on my system, most of which I downloaded from the internet, from the web. And I'm going to go over to my command line on this directory, and I can use a tool from sysinternals called streams. Streams is a command line tool that allows us to examine alternate streams in files if there are any. So let's see that in action. So streams requires a file name or a directory name. So let's say I'm going to look at hello.txt, just that simple text file I created using Notepad. And you notice it says absolutely nothing, which means that there are no alternate streams in this particular file. However, if I take a look at something else here, for example, this, let's look at debug diag. I have some kind of tool I downloaded from the web, and we see that there is a stream there that has the name smart screen, and it has the type is $data, which is kind of the default type, just means some kind of data information, and the size of the stream is 7 bytes exactly. Let's look at another example. I have a few more files here, such as a download of PowerShell. Let's go with PowerShell. So if I look at PowerShell, some kind of installer here, you can see essentially the same thing, or at least it looks like we have a stream called smart screen again. It has again the type of $data and 7 bytes in size. Let's look at something else, maybe one of my books here. So let's try that. So we have Windows kernel programming, something here as a PDF or EPUB, and you can see here something different. This time the stream name is zone.identifier. These columns that you see, the beginning and the end, they're just as separators. They're not part of the actual stream name. And the stream type again is $data, which is, as I mentioned already, is also the default. But this time the stream length is much bigger. It's 439 bytes, much bigger than the previous one. So the thing is that this thing is another kind of a file within a file. And we can see that more clearly by looking in little more details within these alternate streams. So streams is a nice tool, but it only shows the length of the streams and the list of streams. But we can use another tool that I've written many years ago. In fact, it pretty much needs an update, significant upgrade, which is called NTFS streams. You can see it's from 2016. I'm going to open one of these files. Let me open first hello. Notice that it says that in this hello there are no alternate streams, which in fact were verified with the streams tool. Let's open something else like the debug diag MSI. And you notice that now we do have a stream, just the one. And you can see in fact it is 7 bytes in size, and in fact these bytes contain this particular set of bytes, which seem to be Anaheim as a string. I don't know what that means in particular, but probably means something for the smart screen application. Anaheim is a city in California at the very least. So I guess that's probably from there, but I really don't know. These streams might be useful to certain applications. Let me show you another example. Let's go ahead and open the kernel programming book here or something. And we've seen already that there's a much bigger stream here. You can see it 439 bytes and has some data here, some information here. As it happens, this is also some kind of text, And in this case, the name of the stream is zone.identifier. In fact, this is something you might have encountered in the past for sure. If I go ahead and right click this file and go to its properties, you'll notice that there's this thing Explorer shows at the bottom, says security. This file came from another computer, might be blocked to help protect this computer. So if I go ahead and unblock it, so in fact this thing is something that is displayed by Explorer because of that zone.identifier alternate stream. If I go ahead and click apply here or OK, you'll notice that when now I go ahead and reopen that file, this kernel programming book file, you notice it says there are no more streams there in the file. So essentially this thing changed something, and this is a way that Explorer knows that it needs to pop up this extra information about the security of that file. I can even open the entire folder or any folder of my choosing, and I can see all the files that have streams, and for each one that I'm interested in, I can go ahead and double click and see what we have there. Here's another example with zone.identifier, this file called savedate.ics, a calendar invite. And so you can see there's some information here. It doesn't have to be, of course, textual, it could be anything that we want. But essentially we can create any number of those streams within that same file, and they're by default completely hidden. If I add a stream to a file, it is not normally visible. That's kind of interesting. So now let's take a look at some code and see how we can create these streams ourselves. So let's go to Visual Studio. Here I've created a simple console application as usual. I've included windows.h and stdio, and the way to work with these streams is just the same way you work with files. So I'm going to call the create file function to create a file. In fact, I want to create or open a file that exists. So let's go ahead and pick a name. So I'm going to use this directory that I created. In fact, we can go with the hello.txt. Let's go ahead and do that. Or we can create a new one, doesn't really matter. Let's go ahead and perform a write operation here. This is what I want to do. I don't want to share this file right now. There's no need for any special security because I don't really care about that. And then we have the creation disposition. I'm going to use open always, which means that if the file exists, open it. If it doesn't exist, then create it. And then we just need to specify some flags we don't care about, and a template file we don't care about either. That would be a normal way to open a file. However, to open a stream within the file, we need to use the colon syntax here, the name of the stream, such as my stream or whatever name you want. The same rules that we have for file names apply to stream names. And then after another column, you can specify the type of the stream, which is $data, what you typically use, because other specialized types are just used internally by NTFS. But because we typically use this default, we don't actually have to provide it. We can just go ahead and do that, which means the same thing. So $data is going to be the default one that's going to be selected anyway. So once I have that handle, let's go ahead and make sure that we get here something which is valid. If I can type correctly. So if I have something which is not -1, which is invalid handle value, then we can go ahead and do something with the stream. So let's go ahead and write something to it. Let's go ahead and write some text, like a hello stream, something like this, and just use the normal write file function to write data to the stream. It doesn't have to be a text, of course, can be anything we want. Let's just write whatever. So we have the buffer, which is our text. The size of the buffer is going to be the size of this array in terms of bytes. Number of actual bytes we've written, we have to get it back, and we don't care about asynchrony here. So we have the word here with ret, so everything should work out fine. I'm going to close the handle to the file, which in fact is just closing the handle to the stream. So let's see what happens here. Let me first place a breakpoint here and see what happens when we get to this call. So I'm going to run this and then step over this particular create file call. So let's see what happens. So here goes, we get a handle here which has a value A8. This is a valid value for a handle. Let's see what that looks like in Process Explorer. So our application is called Create Streams actually. You notice the file handle is right here. It has the value A8, and notice we have the file name, but we don't see the stream name. So the stream name is not shown, it's not provided by whatever APIs are being used here to enumerate handles and the object corresponding object names. The stream name is completely internal, is not visible normally, but we have a handle to the stream. Let's make sure. Let's go ahead and run this to completion. And now we can go ahead and check these things using tools. We can start with streams by looking at hello.txt. And now we can see there's a stream here with the name my stream, and the length is 17 bytes. And that's because the string here is 17 bytes in length, and of course we have to add the 0 terminating null character. And of course we can look at NTFS streams by opening hello.txt here. So we can see not just the length, but also the actual data here, which is hello stream, as we suspected and expected. Now, going back to the code, let's do a little change here. Let's go ahead and write lots and lots of data. Maybe don't just these 17 bytes. Let's create another stream called my data. I'm going to add a loop here. It's going to do that something like, let's say, 10,000 times. I'm just going to write the same string 10,000 times all over and over again. And I'm going to go ahead and again we can look at the breakpoint here and then try this again, and we'll see something very similar. If I go ahead and just step over this one, I can see that we have a handle value here which has a value of A0. And again, if we go to create streams, we can see A0 here just pointing to the file. We don't see the stream name at all, we just see the file name. Now let's continue to completion. Let's run it to the end. Okay, we're done. So going back to hello.txt here, notice the size that we get in Explorer without going into too deep says 1K. But in fact, if we go ahead and reload the stream, so I'm going to reload this file, but look at the streams inside it, we should now see two streams. One of them is the old one with 17 bytes, but then there's a new one with 170K. So there's lots and lots of data here, but it seems to be completely invisible to the cursory look. Because notice that Explorer says, hey, it's just 1 kilobyte. But in fact, I can put in these untrained streams any amount of data that I want. Really, anything I want can be as big as just like any other file. I can put lots of megabytes or gigabytes within an untrained stream, and still, just looking at the file from a superficial view here in Explorer, it just says 1 kilobyte. If I go ahead and look at the properties, this time we can see the secrets being kind of shown to us, because the size says 8 bytes, but that's just the default stream. But the size on disk seems to be much, much bigger, which in a usual case you would say, hey, something here has gone wrong, it can't be. Why is it taking so much space on disk where it's only 8 bytes in size? It doesn't really make any sense. But for NTFS, it does make sense. It just means that the other data that's in this file is in some alternate streams, which are not counted towards the normal size, so to speak, of the file. I wonder what would the getFileSize API say if we try this thing ourselves by using the getFileSize API in code. So let's go ahead and try it. Let's open the same kind of stream and let's try to find the size of the stream. So here I'm going to use a size and call the function getFileSizeEX just to get very easily the final. You know what, I'll just go with the simpler function because the file is not going to be greater than 4 gigabytes. I'm just going to give it the handle to the file, and I'm not expecting a 32-bit high byte there. And we expect to find the size. I don't know what to expect exactly, so let's go ahead and give it a try. So let's just display the size here, like so, and run this. I'm going to press Ctrl F5 to run this, and this is what we get. We get the correct size because it's the size of the stream. But the size of the file is still 8 bytes, which means that if I open a handle to the file itself, which just means the default stream, let me just go ahead and do that real quick. So I'm going to generic read here, it's going to be good enough. And I'm going to open an existing file. And if that works, then we can try it out here as well. Let's just go ahead and do that. So we have size of file, which is really what it actually means is the default stream. So if we try this out, I'm running that, and here's what we get. We get 8, which is exactly what Explorer shows, because what it shows in size is the default stream, because it just shows, opens a handle to the actual file, which is the thing that works for all file systems. But for NTFS, we have something kind of unique with these alternate streams, which can be used for any purpose, really. It's really up to you to do whatever you want, but one thing you could try to do with that is to hide information or add metadata to the actual data that is normally consumed via the file. Just like that zone.identifier, which is used as metadata to store information that then someone else, some other application, like in this case Explorer, looks at and then does something kind of special. And you'll find lots of these things occurring in various files depending on which files there are, which applications manipulate those files. So these are NTFS streams.